Hello, my name is Azrul. So now I would like to explain about the question today. First, let me read the question first. The question is about describe the instruction set, machine language, and assembly language. So here the answer for the three of them. Instruction set. Instruction set is the complete collection of instructions that are understood by a CPU. Instruction set, also known as machine code. So the instruction set is especially for computer using only. In simple word, instruction set is equal to the internal language of CPU. Next, machine language. Machine language is a binary program, which is we call it as binary code. The natural language of machine language is only 0 and 1. So whatever program that written in any other language, you must translate it to the binary language because the computers only can understand the binary language only. It cannot to understand the human language. The last one, we have assembly language. Assembly language is a low-level programming language that is closely not the 100% the same one. It is closely to to a computer's machine language, which is binary code. So the assembly language uses mnemonics, or we can call it as short words or symbols. For example, MOV means move, and ADD means addition. So it is making easier for humans to read and write. So that's all for the question 2A. Now let's we move to the question 2B. The question to be is giving sentences. So let me read it first. The microprocessor contains several groups of instructions designed to write source code. Discuss the group of instructions below with the related example. So there are three types of instruction, which is arithmetic instruction, data transfer or movement, and logical instruction. So here the answer. Arithmetic instruction. Actually, these instructions perform mathematical operations. For example, addition, subtraction, multiplication, and division. So this is arithmetic instruction. The second one, data transfer or movement. Data transfer or movement used to move or copy data from one place to another. For example, I/O devices to memory or memory to I/O devices. So this is two that use in move or copy data. Move, we can simplify it as MOV. Load, we can simplify it as LDA. The last one, logical instruction. Logical instruction perform bitwise logical operations. For example, AND, OR, XOR. So that's all from me. The questions to see, I will pass it to my friends Lee Kai Sian.
So now I'm going to talking about the question 2C. Find D1 value after instruction execute below. Given that D0 equal to 15, D1 equal to 55. So the question one is move dot B D0 to D1. So dot B is byte, so means that we're using the last two digit. So the data is moved from D0 to D1. So the D0 will remain unchanged and the value of D1 will be replaced by D0. So as you can see here, D1 is changed to 50. Question 2. Add dot B hashtag 25 D1. So dot B means that byte. So add is addition, so we need to make some calculation here. So the hashtag 2 is the immediate value, which is set by the programmer. So in this 25, it is a decimal. So when we are doing the calculation, we need to convert it to hexa so that we can add them together. So it will be 55 add to 19. So here, after you add it, will be 6e. So the final answer will be stored in D1. So D1 will become 6e. Now, we need to do some sub.b D0 to D1. So sub is subtraction. So dot b is byte. So same, we using the last two digit. So D0 is D1 is sub by the D0. So here will be D1 at the first, and then after that D0. So this is the question. So take these two values to make the substitution. So after that, after we sub, we're getting the 40 as the final result. So we store this value into D1. So the D0 will be remain unchanged. The D1 will become 40. Next is mulu. Mulu.w D0 D1. So this mulu is mean that we need to make some multiplication. So .w is word that's been 16 bits. So we are taking a 4 last digit to do our multiplications. So now we're taking the 15 and 55 and then we multiply. So we were getting the final answer is 06F9. So this value will be stored into D1. So the D0 will be remain unchanged. The D1 will be 06F9. Okay, next is divu. Divu is means that we need to make divide. So W hashtag $05 D1. So this hashtag means that the immediate value. So we're using the word, so taking the 4 last digit to make the division. So the D1 is divided by the 5, so the final answer will be 11. So this final answer will be stored in D1. So this remain unchanged, just store in D1. After that is n.b, hashtag $3C D1. So this means that AND is the logical operation. So for AND, both of the value is 1, the final result will be 1. So if one of the value is 0, then the final answer will be 0. So let's look at the B. The B is byte, so taking the last two digit. So now, first thing we need to do is convert this hexadecimal into the binary so that we can compare with the logic. So after we convert it to binary, so let's compare it. After compare, we can get the answer here, which is 00010100. So after getting this answer, we need to change it back to hexa so that we can know that this number in hexa is 14, and then we can store the answer, the final result, into D1. So now is OR.B D0 D1. So it will compare the byte, means that this last two digit with OR operation with D0 and D1. So first of all, changing these two things into the binary so that we can getting this After that, we compare it with the OR logic, means that 1 compared to 1 will be 1. So 0, 0, 0. So as what I mentioned just now, we're getting this value as the final, and then we convert it back to hexa, we're getting 55. So after we're getting this 55, we will store into the D1. So now we're talking about EOR. EOR means like exclusive OR. So .b hashtag S25 D1. So exclusive OR means that both of the value must be different. So means that one of the value is 1, one of the value is 0, then the final answer will be 1. If both of them 1 or both of them 0, will be 0. So compare with byte. So we're taking these two last two digit out and then convert it to binary so that we can compare it. So getting the final answer is 0, 1, 1, 1, 0, 0, 0, 0. So after we getting this answer, we convert it back to hexa, so we get 70. 70 will be put into the D1, so the value is stored in D1. So D1 will be 70. Okay, that's all from my part 2C, question 2C. That's all from us. Thank you.